Hey, dude, space is like really interesting, man. Like, I wish I could see it. All the stars, the constellations, and the planets like every night.
Yeah, man. We should totally go out and see the stars.
But how? There's like so much light pollution here.
Maybe we can get everyone to switch off the lights like this.
Whoa! How did we get here? Where are we? Why is it so dark here? It's almost dark enough to
See the cosmos.
But I don't see anything though.
Here, use this.
That's a reflecting telescope, right? How does it work?
You're right. It works by focusing light from the objects in the night sky using a curved mirror into another secondary mirror, which reflects it into the eyepiece for us to view.
And the other type is a refracting telescope that uses convex lenses to focus the light instead of mirrors.
Yep, that's correct. For the reflecting telescope, we can use bigger mirrors to see clearer. A larger mirror will be able to capture and reflect more light, thus giving it a larger aperture. Also, if we combine that with a longer focal length, we would be able to see further into outer space.
That sounds remarkable. But do these large telescopes exist on Earth?
Oh yes, the Gran Telescopia Canaris is an example of a giant reflecting telescope that is located in Spain. It's currently the world's largest ground-based reflecting telescope. In fact, they have just started building a new giant telescope called the Giant Magellan Telescope.
Oh yeah, I read about it in June. The GMT is a joint collaboration between 11 international partners and will be the largest and sharpest ground-based telescope on Earth. It is made out of 7 large stiff monolith mirrors with each segment 8.4 meters in diameter and a total optical surface diameter of 24.5 meters. Its total collecting area is 368 square meters.
Yeah, the GMT will be 10 times sharper than the Hubble Space Telescope.
Yeah, the surface mirror has to be extremely smooth and consistent. Its surface accuracy has to be within a millionth of an inch, which is about 200 times thinner than a human hair, over the whole mirror surface.
Yeah, and its construction is an engineering feat. Construction requires the use of a large rotating furnace to melt the glass and using centrifugal force to create the mirror. It is then allowed to slowly cool down. The first segment took over 7 years to be produced, with its casting taking 3 months, cooling another 6 months, and grinding and polishing taking a whopping 6.5 years.
That's amazing. With such a powerful telescope, we can see objects and light so far away it might just be possible to observe the birth of the universe, which is over 14 billion years ago.
What? That's a really long way away. Tell me more.
By being able to see so far into deep space, we can see the thousands of galaxies that are so far away from us, and each of these galaxies contain billions of individual stars. Telescopes are like time machines. The further we see into space, the further back we see in time. In fact, by observing the first light of the universe, we would be able to track the life and death of stars, and also the expansion of the universe.
Wouldn't that mean, with this information and knowledge, we would be able to perhaps understand or even predict future events in our own galaxy?
That's right. In fact, we can learn even more about the things we cannot see, like black holes, dark matter, and dark energy, due to their gravitational tugs on the things that we can observe using the GMT.
Absolutely remarkable. And by being able to observe stars in distant galaxies, we can see other planets orbiting these stars too.
You mean exoplanets?
Exactly. We have observed over 4,000 exoplanets of various forms, from hot giants, Jupiter-like planets, icy giants, water worlds, and even diamond worlds. We have even found planets orbiting 2 stars. Looks like Star Wars isn't just plain science fiction anymore, eh? And because we can see so many more exoplanets, there are simply overwhelming odds of finding new worlds, maybe some like our own Earth.
Super Earths. Using the understanding of conditions for life on Earth, we know based on telescopic evidence that there are potentially millions of planets out there that may support liquid water and even life. And the GMT would be able to observe so many more of these Earth-like planets. In fact, within the next decade, the GMT would be able to take spectra of the atmospheres on these planets and determine or not if they have the potential for life.
That is so exciting, lah. When will the GMT be finished?
The first light will be observed in like 2021, but I think it's going to be fully operational by 2025.
I think what's really exciting about the GMT is that it's gonna give us new opportunities to see things in space that we've like never seen and never discovered before.
Yeah, I know, right? And I think maybe perhaps on Earth, it may inspire many young men and women to reach out for the stars, to perhaps understand the universe.